Hey, it's your boy. Welcome to your YouTube channel. I'm kidding. I can't be bothered. I'm not an influencer. I'm just a guy that took apart a dishwasher and a couple other things in the kitchen and wanted to show you real quick some stuff. There'll probably be multi-videos because it's hard to send these over text. Anyways, this is simply just a weight that goes on your faucet. You've probably seen it if you've ever been underneath there. But basically, your faucet hose goes in here. It's for the retractable ones. So you retract it, and then when you're done with it, this pulls it back into its home position. So basically, real simple. It's just clipped in there. Nothing special. Just a piece of plastic and a piece of, heavy metal. But it did have a foam insert to protect the wiring. It would normally be a metal coated wire. So I just thought that was kind of cool. Interesting. Simple. This, I actually thought it was a zinc fish at first, but it didn't really make sense to me why it would be a zinc fish. It was on the outside bottom of the dishwasher. But it actually is a damper. So your rotating arms in a dishwasher are causing a lot of vibrations. So this is just bolted onto the bottom of the dishwasher, which makes it be quieter. Thought it was kind of cool. I think it was like $10 on eBay. Fun fact. This is something I took apart and my fat thumbs can't handle it or can't get it back together. Basically, this is part of a float switch system. Try to zoom this in. How's that? Float switch system, so this black part should actually be down. Where's my screwdriver? So a float switch, as the water rises, a rotating part initiates and pushes this button up. And then as that button goes up, it's actually spring-loaded in here, but I destroyed it. My bad, and my fat thumbs, like I said, can't get it back together. So just imagine there's a little clip here and it comes up, it flicks, rotates, and connects the circuit between these two prongs, which I believe then sends a signal to the sump pump and would then start draining your dishwasher. Also, if it gets stuck, then you can potentially, if you open up your dishwasher and you got water in the bottom of it, it means that this isn't working. So check this and the rest of that circuitry, but this might be your issue. There might be something blocking that. Thought that was cool. It's really small, really ingenious, I thought. Lots of little, pieces in here, pieces of plastic that you don't really know what. It's either structural or it's holding something very small and fine, like this piece of metal that my phone's not gonna focus on that. But it's, very, very thin. So yeah, I'll end this here, but I thought it was pretty cool. Oh yeah, these wires. If you're in robotics, you definitely know what these are. I call them triaxial or coaxial wires, being as there's only two. But basically they are in any small electronics, robotics, any hookups like that. So again, your CAD, very, very little clip that it might not focus on. Very, very little clip in here. And what does it do? It simply holds this in. And it's ingenious. Like, it's so small to me. The tolerances on it, I don't know, must be very small. But it does a job. It keeps this from rattling around. It's great. So this pump is a intake pump, or input, whatever. It brings in the clean water from the city or your town and then pushes it through your dishwasher. So clean water would come through this valve here, or this opening here, be pressurized and shot through here. Yes. This is all your motor pump area here. So we have really clean water out here in BC, a slight brag. So over 10 years, this is the only amount of dirt that you actually get in here. So we're doing pretty good. But if you have any clogging issues or your water seems to be highly pressurized or whatever, this might be an issue with this mesh filter. Might clean it out. How do you clean it out? I don't know. Probably just buy a new dishwasher, to be honest. What else we got? Let's see. Let's do this one next. All right, part 3. This is what I believe is a circulating pump. So basically its job is to maintain the pressure of the clean water and then feeds it to the spraying arms and allows the other pump, which I'll get to because it's the coolest thing. And it allows the water to be a high pressure and then allows the dishes to be cleaned and whatnot. So, you got your motor, a couple circuit boards, connections, some nice soldering, gotta say. This will rotate. So I'm not sure how this exactly works because I took it apart a couple weeks ago and I don't remember. But I was kind of blown away. You pay about $900, I think, for a dishwasher, and it's running off of plastic gears, which is cents to make these things, right? Like, these things are being en masse. Anyways, this will rotate, as you can tell. There is cams in here. Might be able to tell if I had proper lighting. Anyway, there's cams in here. It is actually supposed to be down all the way, but I didn't want to. I want to make this quick and easy. So basically, this cam will come in, click on this little jet out. Oh, there we go. And then click this normally on button. Super simple. I mean, we could make this stuff. It's so easy, and it's crazy that dishwashers are this primitive, in my opinion. You know, we can get this is what, 1 cent for one of these things, and you pay $900 for a dishwasher. So, anyways, that turns on. These gears will then rotate. Actually, no, this motor should be turned on first, which will rotate everything else and complete the circuit. I believe this will indicate to the circuit board either a cycle count or that the cycle has started. I'm not really sure how these things work because it depends on the circuit board and what information it's getting. But I thought that was pretty cool, and also very stupidly simple. So in your CAD designs, I mean, this is just a spring, plastic made piece, goes around a little tube. I thought it was rather primitive, and I like it. Engineering's simple. Engineering's easy, guys. And then this one, I'll do this as a separate video because it's cool. All right, I believe this is part 3, part 4. Can't really remember. So this motor and pump that is gone is what rotates the washing arms with a high pressure water. This is your drain pump, the big heavy thing that drains the wastewater. As you can tell, there's some scum. This is the wastewater. So the water would come into a housing here. Normally one pipe comes in, the other pipe comes out. Obviously I tore it apart because why not? So this is a big heavy thing. This is probably pretty expensive in comparison to the rest of the dishwasher, individual parts anyways. So yeah, taking it apart, this impeller is magnetized. That's how it rotates. And it rotates because it goes in here. And then this is motor. You would apply voltage or an electrical energy, shall we say, to this coil wrapping or copper wrapping. And it would create a magnetic field. As mechanical engineers, we should know this. But it would create a magnetic field. I guess not in here, it'd be over here through this housing and rotate the impeller. So it does, as you can tell, it has a home position. And if I keep going, it will rotate the other way. There you go. Oh, maybe you don't see it. Anyways, so take out the magnet. As a magnet, right, you apply your voltages, magnetic fields on, off, on, off. It'll create a rotation. This thing comes out. And again, you just have plastic housing. Nothing really cool here. It's just plastic housing. But again, think about your designs, screw holes, bolts, things fit in. This motor fits in just perfectly. So consider that stuff with your designs. This motor is quite heavy. Oh, I did not know that came out. Oh, that's new. That's cool. Sweet. More cool stuff. Anyways, I would like to try and make this thing work in some sort of design at home. Yeah, it's quite heavy and generally pretty powerful. So yeah, just thought that was cool. This is a dishwasher. Pay about $900 worth, and cleans your dishes. Much more fuel efficient, much more water and energy efficient than doing it by hand. So please, for the love of God, wash your dishes in the dishwasher as much as possible, and purposely buy stainless steel and other ceramics that would be safe for a dishwasher. That's about all I got for dishwashers. So I think that's the end of this series. Welcome to my YouTube channel. Subscribe, like, thumbs up. I don't remember what they all are. And I hope you guys are enjoying your newfound engineering degree. All right, part 5. I also forgot that I took apart a rechargeable flashlight. So you open it up, which was a pain. I didn't realize there was a screw underneath one of the barcodes. But anyways, this is your motor. It didn't work, so I was like, okay, well, why doesn't it work? And if it doesn't work, it's also very old, from an old camping set that hasn't been used in 15 plus years. So anyways, this is our motor that you would then rotate with this handle by hand, and it would create energy or transform energy from mechanical to electrical and charge this lithium battery. The reason it didn't work was because one of these lines was broken off. So if I had a soldering kit, I could probably fix it, make it work. This is a 4.8 volt battery or motor. And yeah, so if I had a soldering kit, it could work. But here's the other side of your lighting. So some D1, D3, was that L1, R1? Whole bunch of stuff in here. Circuit nerds would love it. Let's see if I can focus that. There you go. So yeah, if you ever want to make a flashlight, this is how you do it. Take notes. Circuit board seems pretty simple. Could probably remake this. Whoops. Circuit board seems pretty simple. Battery takes up most of the room. But yeah, if I had a soldering kit, could probably fix it, to be honest. Also, plastic gears again. Very simple, very cheap. Buy this at Walmart, probably. Yeah, I think that's all I got to show. But yeah, soldering kit, 3D printer, welding booth would be nice too. Oh yeah, and the button to turn it on. I mean, we've seen these buttons before in class. So yeah, I just thought it was pretty cool that some of our classroom stuff actually is relatable to the real world. Who knew? Maybe that degree was actually worth paying for. So anyways, this is the engineering stuff that I find at home to keep me entertained while I'm looking for a job. Yeah, enjoy your summer.